Continuing the story on observability, this now is about multi-cluster observability, an extremely important and probably also quite difficult topic, as you will be presenting the lessons learned from that. Two senior Red Hat product managers from the observability landscape. Really looking forward to having Vanessa Martini and Roger Floren teaching us the lessons learned. Let's have it for the two.
Thank you. Thank you so much. Welcome to our session. So we will talk about our session focus on best practices for effective multi-cluster observability, our lessons learned. So a quick introduction, my name is Vanessa. I am an observability product manager at Red Hat, working on OpenShift analytics and UI topics. And today I'm joined by Roger.
Yeah, hello everybody, my name is Roger. I'm working also as a product manager for observability, focusing on the in-cluster stack in monitoring and also the multi-cluster that we focus on the ACM and some work in Kepler, but that's another story.
Awesome, thank you so much, Roger. So let's get started. What we will talk about today, so we have quite of a packed agenda, as you can see. So we will start by introducing the importance of observability, especially in multi-cluster environments. We will then deep dive into the key challenges we have identified dealing with multi-cluster. And then these reflections will lead us to the heart of today's presentation, which is our lessons learned. What did we learn from all these challenges and what are our recommendations to you all? And last, we will wrap up the presentation with an overview of what's next, hot topics and future trends in the multi-cluster observability space beyond 2024, according to our humble opinion. So let's get started with our first introductory section. Observability multi-cluster environments. So, to reflect on the role that observability plays, I'd like to start with a concrete example. In this case, airports. And with one question: what makes a great airport experience? Well, at this point you may think, that depends. That depends on individual preferences and expectations, and that's totally fair, yes. But now, imagine the dissatisfaction of passengers, including yourselves, waiting hours and hours in line through security controls, and ending up with your flights being delayed. And on top of this, imagine, once landed, your only baggage being lost, nowhere to be found. That would be stressful for any of us, trying to arrive safely, but also chilled at the destination. So let's not forget that this chaos would also be difficult to manage for the airport personnel, dealing with a constant flow of complaints. So then we could all agree that being at an airport, especially during busy, chaotic times, can be overwhelming. There are so many processes to follow from the moment we arrive there to the moment we board a plane. So automation is key here, as airports have to manage thousands and thousands of passengers every hour. And that is when a solid observability platform becomes a must-have, a non-negotiable, not only to guarantee customer satisfaction, but also to prevent issues generally from occurring. So nowadays, more and more organizations that want to improve their own IT resilience, but also scalability, manage workloads more effectively, including AI workloads in this AI era, and generally want to stay competitive in the market, decide to deploy different components of their applications across multiple clusters. Making sure that critical services, especially the customer-facing ones, are always up and running no matter what, no matter if one cluster goes down. So, based on this context, how can observability be best defined, and what role does it play in multi-cluster environments? Let's find it out with Roger.
Oh, I think we jumped one slide. Sorry. One second, what happens here? Yeah, so we have a quote here that we really liked, that observability is a system property that defines the degree which the system can generate actionable insights. What do we mean by that? It means that it's not about just collecting the data, it's also about transforming that data into some actionable insights. Think of it this way, like if you have a multi-cluster environment, it's like a super vast landscape. Observability is like not only the map for you, it's the compass, the binoculars you use to navigate this landscape. So in other words, observability comprised by these pillars that we all talk about by metrics, logs, and traces allows you to answer any question that you might have about a running system will also help you resolve issues within the system. So within this observability, you can the goal is to pinpoint the system's problems quickly, so not trying to dig through the logs as you did before. You want to predict and prevent issues before they happen. The goal is also to optimize performance and efficiency, things like that. So we also like to talk in analogies. And imagine yourself being a pilot of an aircraft, similar to a multi-cluster environment. So your responsible is to navigate this complex machine through the skies. All you need is a clear, concise, and timely information. The same is true for managing a multi-cluster. It's a complex system. It has countless moving parts. And without the right information at the right time, it's easily to feel overwhelmed, make mistakes, or miss these critical issues. So in a cockpit, we rely on these gauges, warning lights, communication systems. So what we think is in a multi-cluster environment, and that's what we're trying to do, is to create this cockpit view of your multi-cluster environment. Like you all know, this single pane of glass that gives you the most relevant information at the time when you need it. This way you can focus on making informed decisions, respond quickly, and just look at these issues that arise. So we have a diagram here that we use a lot, and that is, it illustrates the cycle of observability. It's a continuous feedback loop that drives improvement. You start with that you want better visibility in your system, the foundation of observability. You want to see what's happening, you need to collect all this data, and all the layers of your application stack, like metrics, log, traces, events, and you get better visibility, of course. And what happens then? Yeah, you get a better understanding of your system. Now you can make sense of your data, identifying patterns, correlations, and what's the root cause of some problems that I have. Well, that will build you a better system. And you can use those insights to optimize applications. You can optimize your infrastructure. And then you can spend some time to do even better instrumentation. You can instrument your applications, maybe with traces and your infrastructure, gather even more granular and relevant data, and that will ensure you to collect the right metrics. And what happens then? We're back to you get even better visibility. So it will resolve faster and faster, and you will get a better understanding of your system. So as we've seen, this observability data holds immense promises, but the multi-cluster environment presents a unique set of challenges, and that can make observability more difficult. And the challenges stem, I would say, mostly from the sheer complexity and the scale of a distributed system and all the data. So in the next few slides, we will explore some of the most common challenges that we've seen and we think that organization will need to take a look at, and trying to implement observability in a multi-cluster environment.
Great. So let's start with challenge number one, which is building a single pane of glass, as Roger mentioned, or a so-called unified solid view across all these clusters. So when operating in multi-cluster environments, building this solid view can be challenging. And I'm pretty sure that this is the case also among a lot of you. So why? Clusters can be distributed across different geographical locations, but also operating in multi-cloud and hybrid environments, which may lead to discrepancies, not only in configurations, but also policies, for example. Second, as the number of clusters increases, the volume of our data exponentially increases. So having complete visibility on this large data volume may become a tricky task. Think about tracking the functionality of thousands of dashboards, each one of them focusing on a specific metric component. So that's not easy to do. Last, observability signals might have different formats or schemas. So given the different technologies out there, which makes the normalization, but also the unification and the correlation of this data difficult, especially if collected from multiple clusters. So that complicates the full data analysis process. And this topic automatically leads me to challenge number two, which is dealing with alert noise and increased troubleshooting complexity. As I already mentioned, as the number of our clusters increases, the noise generated from this data increases as well. So focusing on the diagnostic data that matters won't be straightforward. Let's reflect on one use case here, alerts. Interestingly, the majority of alerts looking at our own platform results to have warning status. So detecting critical incidents, especially without any automated tools, would require tons of manual effort and also a huge cognitive load for any colleagues attempting to troubleshoot effectively.
So the other thing we want to talk about, I think we are now challenge 3, resource control. And this is everybody's nightmare, I think. Managing resources across multiple clusters is like, it's like trying to conduct some kind of symphony with an orchestra, but all the musicians are in their own room and don't listen to you. So it's a complex undertaking. It's going to require coordination, careful planning, and the ability to see the big pictures. So the complexity of multi-cluster environments is like, it leads to increased risk of overhead cost. Like, you need to monitor and optimize resources, and you need to understand which resources do you want to collect, which ones do you need for your cluster to understand your settings. And additionally to that, like, capacity planning becomes much more complex. You need to forecast maybe demands and allocate resources that goes across these multiple clusters, taking into account that you will have varying factors, like varying workloads. There could even be seasonal fluctuations if you're a business that relies on different holidays. And of course, unexpected events. How do you take height for that? And to make these informed decisions about resource locations, you need sufficient granularity of data. You don't need all the data, but you don't need too little data. So how do you get the sufficient granularity? That's one key challenge. You need to be able to drill down to this data, to maybe to individual clusters, and see what's happening on those resources, and also where bottlenecks occur, and where some opportunities for optimization exist. So I would say without proper resource control, you can easily fall into the trap of over-provisioning resources or leading to unnecessary cost, or maybe the worst thing, that you under-provision and that will result in performance issues and unhappy customers. So as our applications grow and evolve, another critical challenge, scalability. I touched that a little, and governance of this data. Scalability is what we talk about is you need to be able to handle the increasing volume of data generated by growing numbers of clusters. It should scale both horizontal and vertically without sacrificing performance. Governance, not many talk about that, but when you have these multiple teams, you have multiple stakeholders, you're involved in managing your multi-cluster environment, you need to establish some kind of clear process and policies for your observability data, because it will include defining roles and responsibilities, setting data standards, data collection, retention, ensuring that you have a compliance with security and also like privacy regulations that we have here in Europe. So without scalability and governance, you risk, as I said before, data overload, some kind of inconsistent practices, security and compliance risks, and also something you may not think of is that as a company you will risk slower innovation, because if you cannot scale your observability, you will hinder your developers and your organization's ability to innovate and adopt new technology. So what have we learned from these couple of challenges we talked about? We talked about that a unified view is paramount. You need to break down the silos and consolidate this data to gain an understanding. We learned that alert fatigue is a problem. You need to prioritize alerts, reduce the noise, probably automate some troubleshooting whenever possible. Resource control that I talked about, you need to monitor and manage that. And scalability and governance, that is critical. We need to build systems that can grow with us. But this is just a few lessons that we talked about and find out during our journey. So in the next session, we will delve deeper into some of these insights and share some best practices that we have and tools that we have used. So I think it's your turn. Yes.
So we have explored some of these challenges in the multi-cluster observability world, but good news is that along the way, we have also learned some good lessons, I would say. So let's get started with lesson number 1, which is the importance of navigating the CNCF landscape and overall and generally open source landscape. So under the CNCF umbrella, we find several open source observability projects. We have heard that also in these presentations during these couple of days. There are sandbox, incubating, graduated ones. But as the number of tools increases, even beyond CNCF, choosing the right tool can be overwhelming, can be very difficult.
So as we dig deeper, you've all seen this picture of all the tools that you have, and we cannot ignore this because open source has a lot of tools and technologies offered by CNCF. And I think for us, CNCF have played quite a crucial role in fostering the open source innovation and observability also, because it's a major focus area. But the problem here is that this landscape is vast and it's ever evolving. You will find a wide array of projects, each addressing different topics. You all know, like for monitoring, you have Prometheus, some kind of de facto standard we use a lot, along with others. You have Grafana, Cortex, Thanos for the storage. For logging, you have all these Fluent, Split, Loki, log aggregation, tracing. You have Jaeger, Zipkin, and also, of course, OpenTelemetry. So this is just scratching the surface. There are other projects out there, and the problem is, what do you need? What do you need for your clusters? What do you need? What data do you like to have? So that's one of the most powerful lessons we've learned in the multi-cluster journey, is that the incredible value of open source brings to the table. Like, as I said, projects like Prometheus, OpenTelemetry, they are not just the buzzwords of today, they actually are backbone of many successful observability implementations. For example, we integrate them in our environment and not excluding anyone. We leverage a lot of these and strengthen them to our use case. So why do we think that you would focus on open source? There are a couple of things. Cost effectiveness, like open source tools eliminate licensing fees, allowing you to invest your resource in other areas. Flexibility and customization, I think that is one of the most important parts. You have the freedom to modify and extend your open source tool, and you can benefit from this community and contribute to it. And if you're ever going to change something in your stack, you're not locked to a vendor. Like, you're not locked to a single proprietary solution, giving you a lot of choice to what you want to control and what you want to do with your data. So how do you maximize the value of this? I think is like invest in your expertise. Have people understand how this works and continue following up on your open source journey.
So to be able to build a single pane of glass, the visualization portion is key. So that is why I'd like to mention the new kid on the CNCF block, which is Persis, which has been recently accepted as a CNCF sandbox project. So what's Persis? Persis is an upstream community focusing on observability visualization, making it an emerging alternative to Grafana. So its starting point was supporting Prometheus, but it's giving everyone the chance to contribute code to account for additional data sources. Besides, why Persis? Through Persis, it's possible to easily modify and create charts, as it allows to define dashboards as code in a GitOps-friendly way. On top of this, Persis is easily embeddable with NPM packages, and it's also support plugins, including data source, query, variable, panel. So thanks to these features, it's easier to integrate charts in your own UI and platform. And shout out to the Persis community, by the way. This is an example of the charts currently supported by Persis that include gate charts, time series charts, markdown panels. As you can see from the screen on the top right, editable panel options are also available. Our observability group has also been working on integrated Persis-powered charts in our own platform. A Persis-powered scatter plot and Gantt chart have recently been integrated as part of the brand new Traces UI. So this is how we're making use of Persis in our console so far, as you can see here. This is the scatter plot displaying span sizes in our Traces UI, as you can see from the bubbles and the color codes as well. And a Persis Power Gantt chart, as I mentioned before, to investigate parent-child spans was also produced thanks to Persis, drilling down into more granular level of information, and you can also drill down with a side panel attributes. Analytics-wise, Correlator is an open source project born within our observability group. It was designed to correlate metrics, logs, alerts, and additional observability signals from multiple heterogeneous data stores, and that includes Prometheus and Loki. It's not yet part of CNCF, but it's a useful solution for those teams that need to manage complex multi-cluster environments and reduce the overall troubleshooting time on clusters, as it allows to correlate signals with different schemas and query languages, so from different technologies. I'd like to mention here that the heart of Correlator is its rules. Correlator uses a set of extendable rules that describe relationship between observability signals and Kubernetes resources. So given a start signal, which is called a domain in Correlator, for example, an alert in a cluster, and a goal, for example, find related logs to that specific alert, the Correlator engine searches for that goal data that is related to the start signal by some chain of rules. Those rules make Correlator a flexible tool, as rules can be added upstream. Correlator is also user-friendly as it's embeddable in graphical interfaces. So for example, today, Correlator is integrated in our own interface, and it's supporting signals such as metrics, logs, as I said, Kubernetes resources, alerts, but also network observability events. Adding traces support is being currently worked on upstream. So visualization-wise, this is how an example of how Correlator works on an OpenShift cluster in this case, displayed in our dedicated troubleshooting side panel. The default display of Correlator's output here is a neighborhood graph of resources and signals. By clicking on each node or icon in the panel, you are directed to the relevant information and UI, so the panel is actually interactive. So from a specific signals, as you can see, an alert, you can go to its equivalent metrics, events, logs, and so on, as you can see from the connections highlighted in this slide. On top of this, the focus functionality highlighted in this slide allow users to easily switch the starting signals and gain new perspectives depending on the troubleshooting questions that need to be answered. Basically, here an example. By clicking on pod and then focus, users are provided with correlated signals and resources to that specific pod, as you can see from the slide.
So we have a lot of innovation. We have another project that also we're working on, and they continue to push the boundaries of what's possible, like in maybe things you haven't think of. Like we have Kepler, for example. This is now a CNCF sandbox project that levers like the power of eBPF to probe performance counters. And it uses machine learning models to estimate the energy consumption of your workloads. So Kepler can then export these statistics as Prometheus metrics, and it will seamlessly integrate with your existing monitoring infrastructure. So I think Kepler demonstrates how open source initiatives can tackle specific challenges. And I think that's our main story here. That's you need to find open source products that you can use, that you can incorporate. And in this case, for Kepler, the resource efficiency and sustainability in your multi-cluster environment, it's somewhat a testament to the vibrancy and the innovation of the open source community, I think. I think we have some examples on the graphs, I think.
Yes.
There.
So this is an example of Kepler in our dashboards. Here the overview page, as shown at the top of the screen. We start by looking at the overall total energy consumption over the last 24 hours. Scrolling down in the middle of the slide, you can see the list of the namespaces that are contributing the most to the overall energy consumption. And users can also access more detailed node information, as you can see from the bottom of the slide. Drilling down and switching to the namespace view, you can see the total energy consumption in a specific namespace in watts and kilowatts per hour by selecting your own time range. But it's not over. It's possible to dig even more details per container. So here I highlighted the top contributions for both PKG and drum power consumption. So all in all, Kepler is a great addition, as Roger has said, for better resource control as the number of clusters increases. A great starting point to enable sustainability tracking as part of your observability solution.
So one of the most significant lessons we learned is that the multi-cluster observability is not just about, we said before, collecting data. It's about also efficiently configuring your tools and all your clusters to work seamlessly across your clusters. So what we've been looking into and working on is like, how do we do this? How do you define this clear objective for our observability strategy? This will guide you through like how your decision making of building like what you need for your organization. What we have looked into is we want customer flexibility. Well, our customers operate in diverse environments. We must offer them a flexibility to choose the signals that matters. Some customers only use logs, some customers use metrics. And so it's a different, so our solution needs to be adaptable, and whether it's on premises, cloud, or hybrid. Cost efficiency. We want to avoid unnecessary overhead and complexity. We try to strive to maximize the use of existing single cluster solutions and then expand them to multi-cluster. And the single pane control. This is, I think, our greatest challenge, is to provide this unified view of a multi-cluster environment. So it's not just about technology, it's about empowering your team, your users, and serving the customers. So we have a work in progress. There's nothing that's on the paper now, but we are trying to strengthen our single cluster story and be able to gradually bring a consistent experience to our advanced cluster management. And that is which is our multi-cluster managed solution, if you don't know that. The main takeaway, I would say, is observability architecture needs to be scalable and flexible. Whether you're managing a single environment or global multi-cluster, your strategy must be able to collect, process, and visualize data in a seamless way. So the goal is to use some kind of architecture for us to cover all these pieces, fit together, enabling teams to gain insights, improve efficiency, scale, and configuration, and be able to push this to the single clusters from a multi-cluster environment.
So, one sentence, as you can see, we love open source. But what are the trends that we can expect next? So, we have seen that open source is the way for us forward. However, there is no one-size-fits-all open source solution. So, we have seen it, we have highlighted it several times today. So choosing specific projects over others may be advantageous for different reasons. That is why before making any decision, understanding your own priorities and weighting them is key. Are you looking for scalability, or do you prioritize providing flexibility to your users? We have also seen that value is not only added by graduated projects, but by emerging ones, such as Correlator, not yet part of CNCF. So it's important to keep an eye on those as well, as they can solve complex problems with a more simple approach.
So as we think about observability, we found this picture, or just like a fun analogy, Lego bricks. These are scattered Lego pieces that represent the diversity of an open source community. And just like in open source, there's an amazing collection of tools and projects, and with different purposes, but each one of them contributing to value and a larger picture of observability.
So there are different shapes, sizes, colors, as you can see from this slide. That's just like the open source project that help us with logs, metrics, traces, analytics, visualization. Each tool is a small part of the full ecosystem, but no single piece can do it all. Instead, they all come together to form something much greater, a flexible, customizable observability platform, what we are striving to build. So what you can expect next? So here our prediction very shortly.
Yeah, so the future of multi-cluster observability, of course, bright. Everybody want to do this. So new technologies approach. So we want to talk about some trends that we have picked up from customers, and that is more focus on edge clusters, real-time processing, low latency, defining the role of traces. Is this for platform or is it only for developers? AI-based insights, revolutioning, predictive AI, need for industry-accepted standards. We have a large problem by ourselves about data standardization. Like standardized data ensures that everybody is talking the same language. Defining observability through infrastructure as code, that's a new thing. More focus on cost management and a lot of focus on sustainability with the AI on the rise. Automated remediation across the full observability stack, including data ingestion, analyze these complex data sets and to automatically identify the root cause.
So last slide, summarizing today's session, we could say that observability is no longer luxury, it's a necessity.
So, and it's also a process of learning, adopting and improving, and it's important to embrace open source community. Explore these new tools, technologies, and strive for a deeper understanding. And we used to say, like, observability, it's not a journey, or it is a journey, but it's not the destination.
Thank you so much.
Absolute spot landing and a very, very comprehensive talk. Thank you so much. Unfortunately, we don't have time for questions, but again, are you around for a little bit?
Yeah, we are
Yes, we are
around if
around.
any of you has questions, so please approach us. Thank you so much for your attention, and yeah, it was quite long, but hope it was worth it.
Absolutely. Thank you so much.
Thank
And
you.
Speaker gift.